Hey everybody, hope you're having a good winter break. In this video, we are going to cover verifying trigonometric identities. So to verify means to show that something is true. So in these examples, we have these kind of crazy looking equations, and we want to show that those two sides do in fact equal each other. And as we go through these examples, the tricky thing is that there's not like one set way that works every single time for all of these problems. And that's why I mentioned in our last class that Unit 5 is a lot about problem solving and learning to think outside the box and kind of just accepting the fact that it's not always going to work exactly the same. So, like when I give you rules and hints and that sort of thing, like for example here, sometimes it's helpful to do this, but that's not always the best way. And that's what can make it challenging too. And really the only way to get good at this is to just really do the practice and to really just try these until you start kind of getting the hang of it. The first thing is to memorize the identities, or at least have them somewhere that is easy for you to quickly look at them. Because the better that you have those identities in your brain, like for example, when you see sine squared plus cosine squared, boom, right away, if you know that's 1, that makes your life a lot easier. So with that being said, let's talk about our Pythagorean identities and their alternative forms. And we did talk about this a little bit when we did the lesson 1 notes, but let's just write down the originals. All right, this next one, so let's see if we can figure it out. If I divide everything by sine, so sine divided by sine is 1. Cosine divided by sine is cotangent. 1 divided by sine is cosecant. All right, now let's do it again, but this time we're going to divide everything by cosine. Sine divided by cosine is tangent. Cosine divided by cosine is 1, and 1 divided by cosine is secant. Okay, so there are 2 alternative forms for every identity. For example, I can rearrange these terms here, and I could say sine squared theta is 1 minus cosine squared theta. All I did is I moved this cosine term over to the other side. In the same way, I could move sine over, which would mean that cosine squared is 1 minus sine squared. So that's what I mean by alternative forms. All we're doing is we're taking the same parts and we're just kind of moving them, rearranging them around on either side of the equal sign. So same thing. Let's say I move this cotangent term over. That would mean that 1 equals cosecant squared minus cotangent squared. Same thing if I move over the 1, cotangent squared is equal to cosecant squared minus 1. And I can do the same thing here. 1 equals secant minus tangent, and tangent equals secant minus 1. And the reason why I have you write all these out is because sometimes you might see something where it says like 1 minus cosine squared. And it's helpful to know that 1 minus cosine squared is really just sine squared. So you might see these Pythagorean identities show up in their alternative forms. Basically, anytime that I see trig function squared and a 1 in the same expression, I kind of assume that I'm going to use a Pythagorean identity somehow. Now, again, that's not always the case, but I do look at these to see, okay, can I change this into something a little more simple? Okay, so when we are verifying identities, you rewrite the more complicated side to match the simpler side. So basically, we're only going to change one side. So when we do this, we are going to leave cotangent plus 1 alone, and we are going to move stuff around here, simplify stuff until we can get this side to match that side. So we're only going to change one side of the equal sign. Sometimes it's helpful to write everything in terms of sine and cosine, but again, it's not always. Okay, a lot of times it is. Verifying is not solving. We are not changing anything about the expression. We are simply rewriting the expression in an equivalent form. So I'm not dividing anything. I'm not like taking the square root. We are simply rewriting things in equivalent forms. Okay, so let's verify some identities. So like I said, when I look at this, this seems more simplified to me than this side. So I'm going to leave the left side alone, and I'm going to rearrange this right side to try to match the left side. Cosecant is 1 over sine. So I'm putting things in terms of sines and cosines. And now I'm going to distribute. So that gives me cosine over sine and sine over sine. Cosine over sine is cotangent, and sine over sine is 1. So boom, they are indeed the same. They are indeed the same. All right, let's try example 2. I see lots of squared stuff with 1s. I'm going to rearrange the right side again to try to match the left side. So I see this 1 plus cotangent squared. So I'm going to look up here to see if 1 plus cotangent squared is something. And boom, it definitely is. 1 plus cotangent squared is just cosecant squared. So I have tangent squared times cosecant squared. Now I'm going to turn these into sines and cosines. So tangent squared is sine squared over cosine squared. Cosecant squared is sine squared. Now these are going to cancel out, and I'm left with 1 over cosine squared x. Okay, so it seems like I'm almost there. Are these the same? Yes, they are. This is one of our alternative forms of the Pythagorean identity. Cosine squared is the same thing as 1 minus sine squared. So I can write this as 1 over 1 minus sine squared. And boom, verified. Get that blue check mark. I'm dumb. Okay. Example 3. What side looks more complicated? I don't know. They both look kind of complicated, huh? Looks like the last time I did it, I changed the right side. We can do that. Okay, so I'm going to change the right side, try to make it match the left side. You could do it either way. They both look relatively complex. So what I notice here is that these are two separate terms, whereas what I'm heading to is one term. It's combined together. So I know that I'm going to have to combine these somehow. And this example is probably about as complicated as things are going to get for us. So secant squared is the same thing as 1 over cosine squared. Cosecant is 1 over sine squared. All right, scratch that. We are going to go the opposite way. I'm sorry. Starting over. Okay. We're going to go from the left side to the right side. I want to make my left side match the right side. So we have to actually split this up, right? Because it's one fraction right now. We're going to split it up. And this is a fraction that we love. So I can write this as tangent over sine times cosine minus cotangent over sine times cosine. And now I am going to write this all in terms of sines and cosines. So this is really sine over cosine over sine times cosine. This one is cosine over sine all over sine times cosine. Okay, now we have a fraction divided by something else. Dividing by this is the same thing as multiplying by its reciprocal. So I have sine over cosine times 1 over sine times cosine minus, same thing, cosine over sine times 1 over sine times cosine. Cent and cost. Okay, now we can see a little more clearly how things are going to cancel out. I have a sine and a sine that are going to cancel out. And here I'm going to have a cosine and a cosine that are going to cancel out. So I'm left with 1 over cosine squared, because I'm doing cosine times cosine, minus 1 over sine squared. And guess what? 1 over cosine is secant. 1 over sine squared is cosecant squared. And that's it. That's what we want that to match up to be. That one was definitely a very tricky one. More or less for that one, I would hope that you are able to at least follow along and see the steps that it would take to do that. Numbers 1 and 2 are more at the level of what you're going to see in the homework and what I would expect you to be able to do on your own. We are not going to worry about example 4 today. So the homework is just more practicing with simplifying. So simplifying just means you're combining stuff together. You can skip number 8. Don't worry about doing number 8. And on page 10, it says simplify to a constant, which is a number. So your answer might be like 1 or 0. A single function, or a power of a function. So what that means is your answer might just be sine, or it might just be sine squared, but it's just going to be one singular function. The last ones are where you are verifying. So that's like the examples that we just did together. So that's what you're working on for me before we come back to school on Monday.